In this video, we'll be going over some harder examples for factoring perfect square expressions. So if we look at our expression x squared y squared plus 2xy plus 1, we'll notice that we can write x squared y squared as a perfect square term of parentheses xy squared, and our 1 is simply just 1 squared. So this would fit our perfect squares formula with a equals xy and b equals 1. So this means our 2ab term is simply equal to 2 times xy times 1, which is just equal to 2xy, which is the same as the second term in this expression. So we can rewrite that as 2 times xy times 1. So now this entire expression is in the form of a squared plus 2ab plus b squared, where a equals xy and b equals 1. So this entire expression is equal to xy plus 1 all squared. And this is our final answer. So let's talk about whether or not an expression is even a perfect square for a moment. The first thing to look for is whether or not we can rewrite two of the three terms as a perfect square. So we can see here that x to the fourth y to the fourth is just x squared y squared all squared, and the 4 term is just a 2 squared. So we can set a equals x squared y squared and b equals 2. But when we try to determine our 2ab term, we'll find that it just equals to 2 times x squared y squared times 2, which is equal to 4x squared y squared. And that's not the same as our remaining term, 4x squared y. So this means this expression is not in the perfect square form, and we can't use our perfect square formulas to factor it. And this is something to look out for. Since, in this example, only the first and third terms can be written as a square term, and the 2ab term doesn't match up, this means the expression is not a perfect square. If we can choose other values to set as our a and b, then we would have to try all of them before we can conclude that the expression is not a perfect square, and we'll do an example which illustrates this. So let's take a look at this example. Let's factor x to the fourth y to the fourth plus 4z to the fourth plus 4x squared y squared z squared. So if we look at this expression, we'll see that we can rewrite x to the fourth y to the fourth as x squared y squared all squared, and 4x squared y squared z squared as a 2xyz all squared. So this means we can set a equals x squared y squared and b equals 2xyz, and this means 2ab equals 2 times x squared y squared times 2xyz, which is equal to 4x cubed y cubed z. So if we look at this term and compare that with our remaining term, 4z to the fourth, we'll see that they don't match. So this means we can't use our perfect squares formula with our chosen values of a and b. But we'll see that if we choose different values for a and b, we can actually use the perfect squares formula and rewrite this in the perfect square form. So what we actually should have done was set the first and second terms, x to the fourth y to the fourth, and 4z to the fourth, as our square terms. I'll reorder the expression to make it clear. So this is just x to the fourth y to the fourth plus 4x squared y squared z squared plus 4z to the fourth. So now we can see that we can rewrite our first term as x squared y squared all squared, and 4z to the fourth is just 2z squared all squared. So this means we can set a equals x squared y squared and b equals 2z squared. So we've chosen different terms to be the a and b values, and I'll note that it doesn't make a difference here if we instead set a equals 2z squared and b equals x squared y squared. The important thing is which two of the three terms we have chosen to be our square terms. So with these chosen values, the 2ab term is simply 2 times x squared y squared times 2z squared, which is equal to 4x squared y squared z squared. And now we can see that this matches with our remaining term, 4x squared y squared z squared. So we can rewrite that as 2 times x squared y squared times 2z squared. And now this is in the form of a squared plus 2ab plus b squared, where a equals x squared y squared and b equals 2z squared. So this entire expression is just x squared y squared plus 2z squared, all squared using our formula. And this is our final answer. So let's take a look at this example. Let's try to factor 4x squared y squared plus 9x to the fourth y to the fourth z squared plus z squared. So we can start by setting the first and second terms as our square terms, so we can rewrite this expression as 2xy all squared, which is our first term, plus 3x squared y squared z all squared, which is our second term, and the z squared can remain the same. So we can set a equals 2xy and b equals 3x squared y squared z. So this means our 2ab term is equal to 2 times 2xy times 3x squared y squared z, which equals 12x cubed y cubed z. And we can see that this is definitely not equal to our remaining term, z squared. So this means we can't use the perfect squares formula with these choices for the values of a and b. So now let's try another option for what we can set as our square terms. We can set the first and third terms to be our square terms. So we rewrite this as 2xy all squared, which is the first term, and we'll leave the second term as it is. And then we'll set the z squared as parentheses z all squared, which is basically the same thing. So this means a equals 2xy and b equals z. So 2ab is equal to 2 times 2xy times z, which equals 4xyz. And we can see that this is definitely not equal to our remaining term of 9x to the fourth y to the fourth z squared. So with this choice for what we set as our square terms, this also doesn't work out. So now let's try the remaining option for which of the two terms we can choose as our square terms, which is choosing the second and third terms to be the square terms. We can rewrite the expression as 4x squared y squared plus 3x squared y squared z all squared plus parentheses z squared. So this means we can set a equals 3x squared y squared z and b equals z. So this means 2ab equals 2 times 3x squared y squared z times z, which equals 6x squared y squared z squared. And we can see again that this definitely doesn't match our remaining term, 4x squared y squared. So this means the perfect squares formula cannot be used with this choice of square terms. We have tried every possible combination of terms to be the square terms, and in each case, the 2ab term didn't match up. So this means the expression cannot be factored using the perfect squares formula. So let's do a few more examples with less steps. If we look at the expression, we can see that only the first and third terms are perfect square terms, so we can rewrite 4x to the fourth y squared as 2x squared y all squared, and 25z squared as 5z all squared. And we'll notice that we can also rewrite the middle term, 20x squared yz, as 2 times 2x squared y times 5z. So now, this entire expression is in the form of a squared plus 2ab plus b squared, where a equals 2x squared y and b equals 5z. So this means the entire expression is equal to 2x squared y plus 5z all squared, and this is our final answer. Let's look at this example. We can see that the first and third terms are perfect square terms, and the remaining term, minus 30x cubed y squared z, has a minus sign in front of it, so we'll be using our second formula with the a squared minus 2ab plus b squared. So we can rewrite 25x to the sixth y to the fourth as 5x cubed y squared all squared, and 9z squared as 3z all squared. So we'll notice that we can rewrite our remaining term, 30x cubed y squared z, as a minus 2 times 5x cubed y squared times 3z. So this means that this expression is now in the form a squared minus 2ab plus b squared, where a equals 5x cubed y squared and b equals 3z. So we can use our formula to rewrite this expression as 5x cubed y squared minus 3z all squared. And this is our final answer. Let's take a look at this example. We'll notice that all three terms have an x squared y squared in common, so we'll start by factoring that out from all three terms to make things easier. So If we factor out an x squared y squared from the first term, we're left with a 4x squared y squared. And if we do that with the second term, we're left with 12xy. And if we do that with the third term, we're left with a plus 9. So if we look at the expression inside the parentheses, we can see that it's a perfect square expression because we can rewrite 4x squared y squared as 2xy all squared and 9 as 3 squared. And we can rewrite the remaining term, 12xy, as 2 times 2xy times 3. So the expression inside the parentheses is in the form a squared plus 2ab plus b squared, where a equals 2xy and b equals 3. So we can rewrite that expression as 2xy plus 3 all squared. And if we rewrite the expression by getting rid of the outer parentheses, the entire expression is just x squared y squared times 2xy plus 3 all squared. And this is our final answer. Let's look at this example. Let's factor x plus 1 all squared plus 2 times x plus 1 times y plus 1 plus y plus 1 all squared. We can see that there are two squared terms in this expression, x plus 1 all squared and y plus 1 all squared. So if we let a equals x plus 1 and b equals y plus 1, the 2ab term is simply 2 times x plus 1 times y plus 1, which is the middle term in this expression. So this expression is in the form a squared plus 2ab plus b squared, where a equals x plus 1 and b equals y plus 1. So the entire expression can be rewritten as x plus 1 plus y plus 1 all squared. And we can simplify this further by rewriting it as x plus y plus 2 all squared. And this is our factored expression. So let's look at this example. We can see that this expression is in the form a squared minus 2ab plus b squared, where a equals 3x minus 2 and b equals 5y plus 1. And the minus 2ab term is just minus 2 times 3x minus 2 times 5y plus 1, which matches our middle term. So we can rewrite this as 3x minus 2 minus 5y plus 1 all squared. And we can simplify the expression inside the parentheses and rewrite this as 3x minus 5y minus 3 all squared. And this is our final answer.